Hello, I'm here to do the Math 111 practice final exam. So going into this, you have done a bunch of tests for this class. This is now the final, and it's worth a pretty reasonable chunk of your grade. Usually the final has about 30-something questions on it. The review has a low number, the 30, it's like 32, 33. Usually the final has about the same, maybe upwards of 35 to 37 questions, but you do have 2 hours to complete it. Please study these problems on the practice final. The real final is very similar. The problems will not go in order, so we might get some early on, and we do in this final review, where early problems, we'll have later problems that are actually easier than the earlier problems. So don't think that that's going to be a thing. I know that some professors are letting people have little cheat sheets and stuff, or note cards. Please write down any kind of formulas or examples or some things that you know. There are some things that you need to remember going into it. There's a couple questions where you need to know stuff like perfect squares, perfect cubes, a couple little formulas here and there, little tricks or something like that, so you have an idea of what's going on. Otherwise, without further ado, this first question is one about rational expressions, and it's asking us to simplify. So in the case of this, there's no equal sign. If there is no equal sign, that's all we can really do is simplify. Okay? We're not going to solve it. We're not trying to find x. We're not trying to do anything. Simplify means that there's going to be something on the top and bottom that's going to cancel. Don't think it's x squared. We can't do that. Don't even try to do this. Okay? And say, oh, I simplified that. No problem. No problem there. That's not a thing. Okay? Don't do that. So what we have to do to simplify it is to factor it. That's the first step. We're going to factor it, and they should have something in common that will cancel. You know that they're going to have something in common that's going to cancel. 9 times out of 10 they do. So you factor which one is easier for you. If you think the top's easier to factor, you think the bottom's easier to factor that one first. Once you do that, then you're going to know what the other one is going to factor into. It's going to have one of those factors. So the top one is the difference of 2 squares. Okay? And so to factor this, it is just going to be the same thing. You're going to get x and a 3, an x and a 3. And because of that minus in the middle, one of these is a plus and one of those is a minus. Now I know that looking at this bottom, either x plus 3 or x minus 3 is going to be a factor. I don't know which one yet, okay, but I know one of them will. So it helps me out with factoring the bottom if I found that to be more difficult. It's up to you. So I get x and x, so we're going to factor the bottom now. How do I get 15? Well, 5 and 3. Clearly I know one of them is going to be 3. I know that this is a minus. That tells me one's a plus, one's a minus. This is a minus. And because that's a minus, it tells me that the bigger one has to be a minus. So it needs to be minus 5 and a plus 3. If you're not sure of your factoring, if you're not very good at it, especially if you're not good with your signs, then you need to sit there and try to FOIL this out that we just factored to see if that's going to factor into what this is right here. If not, I think if your signs are wrong, then the whole problem's wrong, okay? Just know that whenever it comes to factoring, if you have x squared blank, like if you have a plus here, something with x, I don't even care what it is, it's a number, and then plus the number on the end, this will always factor into an x plus and an x plus situation. If you had x squared and you have a minus and an x, and then a plus here. Very important that we pay attention to the minus here, but the plus is here. These always factor into x minus, x minus. But in the case of what we just had, if you have x squared, you could have a plus or a minus. Either. It doesn't matter. Something with x, minus here, these always factor into x minus, x plus. Okay? The key point here is this, the minus on the end. Notice neither of the top two, here and here, have a minus. This one does. That's why it factors into that. Okay? Now, I see that they do have something in common, the x plus 3, and it cancels out. The other stuff left over has nothing in common. So, my answer is just x minus 3 over x minus 5. You don't have to put the parentheses there, I just did that. It's totally optional. And this is it, okay? And I'm done with that problem, because that's simplified. Now this next problem. The next problem is asking us to add, okay? You notice right off the bat there's no equal sign. No equal sign. So we're not solving, okay? They're very similar to the ones you have to solve, but we're not solving it because there's no equal sign. If this is something you're not sure of, write this down if you get a note card, okay? Or make notes about it. So, because they're fractions, a they don't have the same denominator, I have to find the least common denominator. So I find the least common denominator between the two of them. Well, they both have an n, but the numbers are different with the, pluses or minuses after n. So the only least common denominator that there is are these two things multiplied together. So it's n plus 5 times n plus 2, okay? I'm not going to FOIL it out, I'm just going to leave it like that. So here's the deal. This one, this n, is missing this one, okay? And this one over here, the 6, is missing this one. So some people will say that you're going to cross multiply. You kind of are, but you're not. Cross multiplying is something completely different, but we are going to multiply those opposite ones together. And then we're going to use our common denominator. So how this looks is I'm going to have n times n plus 2. This first one here that I just talked about doing, okay? Plus, now why is it a plus? Because the symbol in the middle is a plus, okay? And I'm going to use a different color to make it easier. This times this. So 6 times n plus 5, and then this is all over my LCD. N plus 5, n plus 2. Now you might be thinking, oh, can I just start canceling? No, you can't. What we want to do is we want to multiply out the top, simplify, and then see if we can maybe do some canceling or some more factoring, okay? So here, if I go ahead and multiply out the first one, I get n squared plus 2n, multiply this out, and I get plus 6n plus 30 here. All over, I just rewrite this, n plus 5, n plus 2, okay? Now here, I have some like terms I can combine. Let's go ahead and do that. N squared plus 8n plus 30. Now, in some cases, this top could factor. It doesn't here, which is nice. So the top doesn't factor, so this is my answer. But in some cases, the top will factor, and then maybe you might be able to cancel one of those. But we don't in this situation. This is my answer. I leave it alone. Okay? So remember, there's no equal signs. We're not solving it. We're just doing this. We're going to get an answer like this, and we're finished. All right, let's move on to the next problem here. Okay, the next problem is asking us to subtract. Well, they're giving us a very long thing here. In the case of subtracting or adding, whenever you have multiple terms, you never change whatever's in the first parentheses. That's going to stay exactly the same. But if you're subtracting, the stuff in the second parentheses is going to change everything. All of these are going to become a different sign because you have the minus. So they're going to change signs. If they're positive, now they're negative. They're negative, now they're positive. Let's go ahead and do that. I'm going to rewrite everything from the first one exactly the same as you see it. Okay. See, everything's the same. Now I start multiplying this minus in. So I get minus 7x to the 4th plus 3x cubed, because I changed that, minus 11x squared plus 15x minus 8. All of the signs change. Please know that. Don't miss some on the back end. Now from here I start combining like terms, things that have the same variable and exponent. I have a 9x to the 4th and a minus 7x to the 4th. Put them together and I get 2x to the 4th. Now they're done. In some cases it helps to cross out these if you have a lot of numbers. It just helps you figure out what's disappearing, what's still there. Now I go to my 5x cubed and I have a 3x cubed. Put them together, I get 8x cubed. And I'm finished. Now I have a 3x squared and a minus 11x squared. I put those together. Remember, it's a minus 11, so I'm going to get negative 8. Negative 8x squared. And I'm done. Now here I have a minus 1, but I do also have this 15x. It doesn't have a partner to go with. So because of that, I just copy 15x. Just comes along. Now it's gone. I have minus 11 and minus 8. Putting them together, I get minus 9. I check my answer here to make sure I didn't accidentally write something twice, or I could still do some simplifying, and I can't. So combining these all together gives me this answer. Now let's look at the next problem. Okay, the next problem says determine whether the set of ordered pairs is a function. Provide your reasoning and find the domain and range. Okay, first let's find the domain and range, then we'll decide whether or not it's a function. So domain is all the x's, range is all the y's. It's easy for you to remember, D comes before R in the alphabet, just like X comes before Y. Okay? So I'm going to list off my x's, I'm going to list off my y's. If there's any repeats or duplicates, don't list them multiple times. Some teachers are really particular about you doing it in order. So you don't want to put 8 and then 0 and then -5. You want to do -5 and 0 then 8. So let's go ahead and do that. You know your teacher. You would know which one they prefer. I have a -2 as my smallest, followed by -1. And then I have a 0, a 1, and a 2. None of those numbers repeat. When I say repeat, I mean exactly the same. I look at my y's, and I have the smallest one is a -8, but notice I have it twice. So I'm only going to write it once, okay? Then the next number I have is a 0, and then I have the number +1 twice. I'm only going to write it once. Now notice there's a difference between my domain and range, meaning that one of them has more numbers than the other. Usually that's a bad sign, meaning that it's not a function, but not in this case, because I have more x's than I do y's, okay? So this is a function, yes. The reason why is I don't have two x's going to different y's, so I have no repeated x's, okay, going to different y's, or like, paired with different y's, so paired with different y's. If you're not sure what I mean by that, I'll give you an example. So if I had the points 2, 8, and then let's just say I had 0, -4, and then I had 2, -3, clearly I have the same x going to two different y's. This one right here would be not a function. Just letting you know that, okay? So make sure you know that for your test. This next problem is asking us to solve. Notice what's here, an equal sign. So we are solving, okay? It's not like the other two that we've seen previously. Not at all like it. In this case, this is where you'll cross multiply. How do I know I can cross multiply? I have fraction on one side, fraction on the other side. Cross multiply, okay? So to cross multiply, this 4 times x goes over here, they get multiplied together. And then over here I get 3 times x plus 5. Now please put that in parentheses, and then we're going to distribute that out. Don't just do 3x plus 5 or something like that. It's not going to work. So 4x equals 3x plus 15. Now I just solve like normal. Very simple solving, for x problem. Minus 3x, minus 3x. I end up with x is equal to 15. And I'm finished. That's all I got to do for this problem, okay?